Hello, in this video we are going to solve this exam question on the topic of Taylor polynomials. Okay, determine the Taylor polynomial of this function f of x equals to arctangent of 2x of degree 3 around x equals to 0. Okay, so the function is given to be arctangent of 2x. And the degree is supposed to be 3, so n is 3, and the point around which we want to do this Taylor expansion is 0, so a is equal to 0. So indeed, this is a Maclaurin polynomial rather than Taylor polynomial. Okay, so let us write a formula for P3x. So this is the general formula. This is f prime of a, which is f of 0 in this case, plus f prime of a, f prime of 0, divided by 1 factorial, and x minus a, which in this case will be x to the power of 1, plus f double prime of 0 divided by 2 factorial, multiplied by x minus a, which is x to power 2, and finally f triple prime, the third order derivative calculated at 0, divided by 3 factorial x minus 0 to power 3. So in order to answer this question, I have to calculate these coefficients. Okay, so let us do that. Okay, the first one is extremely simple. F of x is given arctangent of 2x. So this means that f of 0 is arctangent of 0, which we know is 0. So that's the first coefficient. In order to calculate the second coefficient, f prime of 0, we are supposed to calculate f prime of x first. So let me remind you about the formula. If you have arctangent of u is any function of x, differentiable function of x, and if you want to differentiate this whole combination with respect to u, according to the chain rule and what we learned about the derivative of arctangent, it becomes u prime divided by 1 plus u squared. Okay, so here I want to give the role of u to this expression. So u prime will be simply 2 and u squared will be 4x squared. So f prime of x will be 2 divided by 1 plus 4x squared. Okay, and of course, because I want to take more derivatives, I try to avoid the quotient rule. That is, of course, something subjective. If you want, you can also work with the quotient rule. But I prefer to bring it up and write it with negative power. So it is minus 1, and then for the next time, I will use the chain rule rather than quotient rule. Okay, but now in order to calculate the second coefficient, I have to calculate f prime of 0. So it means that wherever I see x in my derivative, I replace it with 0. If I do that, this term is gone. 1 minus 1 to the power of minus 1 is 1, and then times 2 is 2. So that is the second coefficient that I am supposed to calculate. And now I need another derivative, so f double prime of x. So how should I do that? This is the function, this is the first derivative. If I want to do it one more time, so I give the role of u to this guy, so it is 2u to power minus 1. When I differentiate it, it becomes minus 2u to power minus 2, but I also have to multiply by u prime. Okay, so this minus 1 goes down, so it becomes minus 2, 1 plus 4x squared to power minus 2, but multiplied by u prime, which gives me 8x. Yes? And then, of course, I can simplify it a little bit. It becomes minus 16x, and then I have 1 plus 4x squared to power minus 2, but my goal is to calculate f double prime at 0. So it means that I replace x with 0. And because of this one is 0, everything vanishes and I get a 0 here. Okay, there is one more step. We have to differentiate this expression once more to get the third derivative. But here you see I have a product rule because that's a function multiplied by another function, so I have to use the product rule. The derivative of the first one, which is minus 16, multiplied by the second function itself, plus the first function itself multiplied by the derivative of this function, which I will use the chain rule. U to power minus 2 prime is minus 2u to power minus 3 times u prime. So what happens, it becomes minus 2 multiplied by minus 2, 1 plus 4x squared to power minus 3, but multiplied by u prime, which is 8x. There is no need to simplify this expression because your goal is actually to calculate f triple prime at 0. So we don't waste our time. So f triple prime at 0 means go to your third derivative and replace x with 0 everywhere. If I replace x with 0 everywhere, so this term completely vanishes because of this x over that x. But this one becomes, I made a mistake here, yes? So of course it will not affect the result, but I have to write this minus 2 here. I forgot to put this minus 2 here, okay? But anyway, if I put 0 here, this becomes 1 to power minus 2, which is 1, and then times that is minus 16. And this is finally the last coefficient I need, and then I calculate p of 3x by plugging these numbers back. So f of 0 is 0, so this is gone. F double prime of 0 is 0, so this term is totally gone. F prime of 0 is 2, so it becomes 2 divided by 1 factorial, which is just 2, and then multiplied by x. And the next one is f triple prime, which is minus 16 divided by 3 factorial. But 3 factorial is 3 times 2 times 1, which is 6, so it becomes minus 8 over 3. So it becomes minus 8 over 3 x to power 3. So this is the final answer that we are supposed to provide for this exam question. Okay? Yeah, it is always good to get a feeling how it works by using some applications. So I'm using GeoGebra Classic version 6. It's a free app. Because I want to calculate precise values, I have to switch my view. So I go to here and then I choose cast view, and I don't need algebra view anymore, but I need graphic view, so let me keep it. Okay, and then of course I click somewhere here and then I open up a little bit of a space. So here I want to find my Taylor expansion, so I start typing TAY. So okay, some suggestion comes in and I choose this one. My expression is my function, but arctangent is not arctangent in GeoGebra, so you go to this menu and then you choose tangent inverse, and then you have to, I put a space for multiplication x. Okay, and then x value means around which point you are doing this Taylor expansion, and we know that is a Maclaurin one, so that is 0, and the order was given to be 3. Okay, and then of course you press enter, and then you see that this is the simplified version, exactly the answer we got. But of course it is a good idea to draw the graph, so you click on this circle and then you have the graph of this third degree polynomial. It's also good to see how good it approximates the function, so let me draw the function itself. Y equals to tangent inverse of 2 space x for multiplication, and then you divide, and then again you just click here, and that is your graph. Okay, so now let us focus here. I have 2 green curves. This one is the Taylor expansion, and this one is the arctangent one. And you see that around x equals to 0, in the vicinity, in the neighborhood of 0, we cannot even recognize that we have 2 different green curves. Yes, we think that they are the same. So this means that this is actually extremely good approximation. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.